Hello everyone, continuing with the solutions of the problems from exercise 7.2 on integration. We have already learnt about the solutions from question number 1 to question number 22. In this video, we are starting question number 23 onwards. And question number 23 here is integral of sine inverse x upon root of 1 minus x square. We know the integral of sine inverse x is 1 upon root of 1 minus x square. So we can take this as t. So we can consider sine inverse x as t. Differentiating with respect to x, we get here 1 upon root of 1 minus x square dx as dt. Applying that here, we get sine inverse x, that is t. 1 upon root of 1 minus x square into dx is dt. So this becomes t into dt. And we know the integral of t is t square by 2. So this is t square by 2 plus c. Substituting the value of t, we get 1 upon 2 whole square of sine inverse x plus c as the solution or the answer of the problem. Question number 24 here is integral of 2 cos x minus 3 sin x upon 6 cos x plus 4 sin x dx. What we find in this problem? We are finding that 2 is common in the denominator. If we take that 2 common, it will be 1 upon 2 cos x minus 3 sin x upon 3 cos x plus 2 sin x. What we find here? The derivative of this is available here. It means we can take this particular function as t or fx. So we can write this as let 3 cos x plus 2 sin x equal to fx. Differentiating with respect to x, we will get f dash x is equal to minus 3 sin x, because derivative of cos x is minus sin x, plus 2 cos x, because derivative of sin x is cos x. Applying that here, we get 1 upon 2 cos x minus 3 sin x, that is f dash x, and this is fx, and we know that integral of f dash x upon fx is log of fx, so we can apply it here 1 upon 2 log of fx plus c. Substituting the value of fx, we get 1 upon 2 log of 3 cos x plus 2 sin x plus c is the solution of this particular problem. Question number 25 here is 1 upon cos square x into 1 minus tan x whole square. We know 1 upon cos x is sec x. So 1 upon cos square x will be sec square x. So we can write this as 1 upon 1 minus tan x whole square into sec square x dx. And now we know that derivative of tan x is sec square x. So we can take this particular function as t. So we consider 1 minus tan x equal to t. Differentiating with respect to x, we will get this as 0 minus sec square x dx equal to dt. It means we will have sec square x dx equal to minus dt. Applying this here, we will have this as 1 upon t square into dt with a negative sign, and apply the rule of integral of x power n, we will have this as minus 1 upon t plus c, because this is t power minus 2 and that will become t to the power minus 1, which is 1 upon t. Minus into minus will become plus, so this is 1 upon t plus c. Substituting the value of t, we will get this as 1 upon 1 minus tan x plus c, which is the answer to the problem. And now question number 26 here is integral of cos root x upon root x, and we know that derivative of root x is 1 upon 2 root x. So we can take this root x as t. So we consider root x as t. Differentiating with respect to x, we will have 1 upon 2 root x dx is equal to dt. Or we can say that 1 upon root x dx will be 2 dt. Applying this here, we will have 2 into cos t dt, integral of cos t. Integral of cos t is sin t. So we can write this as 2 into sin t plus c. Applying the value of t, we get this as 2 sine of root x plus c, the answer of the problem. Question number 27 here is integral of root of sine 2x into cos 2x. Derivative of this we are finding will come in this term. So we can take this sine 2x as t or t square if we want to avoid the radical power. Suppose we take it as t, then we write let sine 2x equal to t. Differentiating with respect to x using the chain rule, we will get this as 2 into cos of 2x dx is equal to dt. It means cos 2x dx will be 1 upon 2 dt. Applying this here, we will get 1 upon 2 root of t dt. And applying the first formula, that is integral of x power n dx, that is x power n plus 1 upon n plus 1, we will get here 1 upon 2 t power 3 by 2 upon 3 by 2 plus c, because this is t power half and half plus 1 is 3 by 2. This 2 and 2 cancel. So this comes as 1 upon 3. Substituting the value of t, we have sine 2x whole power 3 by 2 plus c. This is the answer to the problem. Now the next question, question number 28 is integral of cos x upon root of 1 plus sin x. Here also we can take this 1 plus sin x as t, or to avoid radical power, t square. Suppose in this case we take it as t square. So we write let 1 plus sin x is equal to t square. Differentiating with respect to x, we get cos x dx is equal to 2t dt. Applying this here, we will have cos x dx as 2t dt and root 1 plus sin x will be t. So t and t cancel. This is the reason we can take it as t square, because we can avoid the radical power, that is root of t. And now we get this as 2 into integral of 1 into dt. The integral of 1 is t, so this becomes 2 into t plus c. Substituting the value of t, we get this as 2 into root of 1 plus sin x plus c, which is the answer to the problem. 29th question here is integral of cot x into log of sin x. Here we can take this as t, because if we take log of sin x as t, when we differentiate with respect to x using the chain rule, we know log of sin x means 1 upon sin x into d by dx of sin x is cos x dx equal to dt, which becomes cot x dx equal to dt. And this is now cot x dx is here, so we can write this as t dt. And we know the integral of t is t square by 2. Substituting the value of t, we get this as 1 upon 2 whole square of log of sin x plus c, which is the answer to the problem. 30th question here is integral of sin x upon 1 plus cos x. Easily we can see that derivative of cos x is minus sin x, so we can take this function as t. We can consider 1 plus cos x as t. Differentiating with respect to x, we get minus sin x dx equal to dt. It means sin x dx will be equal to minus dt. Applying this here, we get minus dt upon t. And we know the integral of 1 upon t is log of t. So this becomes minus log of t plus c. Applying the value of t, we get here minus log of 1 plus cos x plus c, which is the answer to this particular problem. Question number 31 here is integral of sin x upon 1 plus cos x whole square, and we know the derivative of cos x is minus sin x, so we can take this particular function 1 plus cos x as t, and we write here let 1 plus cos x equal to t. Differentiating with respect to x, we get here 0 minus sin x dx is equal to dt, and hence we are getting this as sin x dx equal to minus dt. Applying that here, we get minus sin x dx is minus dt, and we have already taken minus here upon t square. And we know integral of 1 upon t square is minus 1 upon t. So we can write this as minus 1 upon t plus c, which is minus into minus plus 1 upon t plus c. Applying the value of t, we get 1 upon 1 plus cos x plus c as the answer to the problem. Remaining questions of the exercise we will continue in the next video. Thanks for watching my video. If you have any comments or doubts, leave them in the comment box and I will get back to you.